Hello dear aspirants, welcome to GD's online classes and I especially welcome you for my cognosy sessions. Yes, my dear aspirants, in the last session, up to the last session, we have covered the what do you mean by alkaloids and their physical properties, chemical properties and other properties of these alkaloids. Now, we look into the what are the classification of the alkaloids along with some of the crude drugs, because in the alkaloids, especially for our examination, the drugs and their secondary metabolites like their chemical constants and their uses and their sources, and some drugs, and for some drugs chemical tests also are very important thing. Yes, now we'll cover each classification or each alkaloids with respect to their crude drugs examples. Yes, now in this chapter, now in this session, we are going to cover the one of the major classification in the alkaloids, that is pyridine and piperidine alkaloids. Pyridine and piperidine alkaloids. My dear students, do remember that this classification of alkaloids now we are discussing from now will be based on their chemical nature, based on the structural. Okay, so which means the pyridine and piperidine alkaloid consisting of the pyridine and piperidine ring. So we'll see what are the pyridine and piperidine ring containing alkaloids. Clear? Yes. But before that, what are the chemical structure and what are the other important points with respect to the pyridine alkaloids? Yes, pyridine and piperidine alkaloids are fascinating group of natural compounds present in various plants, fungi and animals. Yes, we do know that these secondary metabolites like alkaloids and some other glycosides, and all these are not only they are fixed to one category, they are can also available, they can also synthesize in plants, fungi and animals. Also we can see this pyridine and piperidine alkaloids, because these alkaloids are possessing some of the biological functions. So for that reason they are maybe synthesized in some other organisms. So coming to the first one, in that we need to know about for every secondary metabolite, for every alkaloid. So in regards of GPAT examination, we should check their other properties, other important things rather than the source, chemical constants and uses. But we need to see holistically what he meant by the holistically the pyridine and piperidine alkaloids. Yes, in that, so we need to check what is the chemical structure of these pyridine alkaloids. Yes, pyridine alkaloids, they are categorized based on the pyridine ring, which means they consist of pyridine ring, as we have seen in this tabular form, right? You can see right over here, yes, pyridine ring and piperidine ring. So these things we are going to discuss. So which means all the alkaloids which consisting or which contain in this structure pyridine, they are pyridine alkaloids. They are consisting of piperidine, they are piperidine alkaloids. But each type of classification, each type of ring, each type of structure will possessing different properties because of maybe the little bit slight variations. Okay, so we'll see. Yes, undoubtedly, the pyridine alkaloids consist of the pyridine nucleus. But you should remember that whenever any term alkaloid comes under in your brain, comes under, so that you definitely think that nitrogen. The nitrogen containing heterocyclic rings. Okay, so that every, except a few pseudo-alkaloids, but almost all the real alkaloids, all the true proto-alkaloids are consisting of nitrogen, either there in the structure, either in the cycle, either maybe from the, apart from the, or beside the cycle. Okay, yes, piperidine. So simply, the piperidine alkaloids consisting of a piperidine ring A, this structure. That's what we have seen in the tabular form. Okay, and coming to the occurrence. So what is the major distribution of these piperidine and pyridine alkaloids in different families, in different types of taxonomical species? Yes, these piperidine and pyridine. Okay, so first we'll see the pyridine. These pyridine alkaloids are commonly found in like tobacco, belladonna and conium maculatum, quinine. So these are nothing but the nicotine, atropine and quinine. So these will be the pyridine alkaloids. So you should remember that. You need to distinguish that. So which one is a pyridine alkaloid and which one is a piperidine alkaloid? So immediately you should know that. Tobacco. So they'll give you in examination. So which one of the alkaloid is a pyridine alkaloid? Pyridine containing alkaloid, yes. Tobacco, TBC. You should remember that. TBC, tobacco. Okay, tobacco, belladonna and conium. Tobacco. So first example is tobacco. So by that you can remember TBC. T, tobacco, P for belladonna and C for conium. So this was the the occurrence or distribution of pyridine alkaloids. So we can see this Well, largely we can found this in the all the species. Whereas piperidine alkaloids can abundantly seen in black pepper, belladonna, and vinca rosea. BBV, black pepper, belladonna, and vinca rosea. Which means they are having this pyridine nucleus. Piperidine nucleus. Okay, so these are the examples. So you should remember that example also. So which one is comes under the pyridine? Which one is comes under the piperidine? Okay, so that because sometimes they ask about their examples also. Holistically they ask. Okay, yes. Next, coming to the first one, now we are going to start with the first drug in this pyridine alkaloid, that's lobelia. So you can see right over on the screen on the right of the corner. So that's the lobelia flowers, that which is a very attractive and bluish color flowers. The bluish color flowers are the lobelia. Okay, yes. So coming to that, what is a synonym with respect to our examination in the especially for cognosy? In the previous and the earlier classes, I said you that we are expecting we can get the questions from the starting synonym to their adult friends, so that we should cover their synonym. Then after that we need to go for the biological, so then we need to check for their chemical contents, and finally if there is any chemical test, any special chemical test are there, should definitely remember that. Yes, we'll say the synonyms, because sometimes most of the questions are expecting from the synonyms itself. Yeah. Yes. Coming to that, this lobelia is known as asthma weed and Indian tobacco. Asthma weed and Indian tobacco. So this was the lobelia synonym. So because you should remember that it is an asthma weed. So sometimes like this special synonyms, they will focus on devil's dung for asafoetida. So like how they used to ask some of the special synonyms, so that you should definitely remember that asthma weed and Indian tobacco is a synonym for the lobelia. But whereas the source of these biological source of lobelia area, that's the reason we have focused here the aerial parts. The lobelia is obtained from that aerial parts, the autumn, the shoot part, especially the aerial parts of lobelia nicotiana. That's the reason nicotiana. Maybe it's consisting of nicotine. That's the reason it's an Indian tobacco. Lobelia nicotiana folia. Campanulaceae. So family is Campanulaceae. Yes. But whereas the main thing we need to remember here is the chemical constants. The first one in that lobelia, lobelin. So the name is saying that lobelia, it consists of lobelin consisting of 0.5 to 1.2% of total alkaloids. And whereas the chemical constants like lobelin, lobelanine, loberidine, lobelanine and lobedin. So these are the chemical constants of the lobelia. Okay, so when coming to the chemical test of these lobelia, sometimes we need to remember this chemical test also for that reason. Lobelia, when it's treated with H2SO4, it will give a red color. And also when the lobelia is boiled, upon heating and boiling, it gives a acetophenone, which means recognized by cell. When we boil this lobelia aerial parts, it liberates some of the smell which is known to be or which is identified as a acetophenone. Yes. So now we look at into the uses. Yes, especially the uses are very important. Sometimes they ask, they'll shuffle, sometimes they focus on uses, and on the right side they'll give you the options. On one row they'll give the drug's name, and another row they'll give the uses, and they'll shuffle the option and they ask you to pick the right match. Okay, so that asthma weed, especially then sometimes the synonyms will describe about the use of the particular drug. So like how? Yes, coming to the sarpagandha, Rauwolfia. I'll tell you the example. Rauwolfia sarpagandha, the synonym of this snake root, which is the name itself saying that use of these sarpagandha or Rauwolfia to treat the snake poisoning, snake bite. Like how? If you remember the synonym itself, we can able to answer the use of the particular drug also. Yes, coming to that, uses. So it used in the asthma, especially we know that asthma is a respiratory disease, so that it can treat the asthma and also it can stimulate the respiratory function. So this is about lobelia. You should remember that what are the source? Lobelia nicotiana, Campanulaceae is known as asthma weed and Indian tobacco. And whereas coming to that, This chemical concept 𝘿𝙂𝙎 contains 0.5 to 1.2% of total alkaloids, and whereas other chemical constants 𝘿𝙂𝙎, 𝘿𝙂𝙎𝑖𝑛E and 𝘿𝙂𝑖𝑑INE uses are asthma and respiratory diseases. So this is about the 𝘿𝙂𝙎. Now we'll see what are the other important pyridine alkaloids. And yes, by looking at image in the right of the corner, you can say what is the image. So we can see in the major, in our food ingredients, and also in some other, mouth freshness, we can see this areca. Yes, areca. So it's the most familiar alkaloid. It is also known as betel nut. It's also known as betel nut. So where we can see in almost all the mouth fresheners, okay, and other preparations which are tend to chew, okay. Yes, like how this areca nut is also known as, the coming to the synonym of this areca nut is supari and betel nut. And whereas coming to that, the source of this biological source of areca nut is Areca catechu. It is a dried ripened seed of, now you look at here, Areca catechu, belong to the family Palmae. The Palmae, believe the Palmae family containing seeds. Some other Palmae family containing seeds may also contain volatile oils. Okay, so we'll discuss the remaining part in the other upcoming classes. But in this Areca catechu, it is known as the areca nut is known as the source of this areca nut is, it is a dried ripened seed of Areca catechu belonging to family Palmae. Yes, but coming to that, what are the chemical constants? The main chemical constants are guaifenesin, arecaidine, arecoline. Arecaidine and arecoline. So these are the chemical constants. You can see right over here how we can get. So the first major chemical constant, the initial major chemical constant is guaifenesin. Upon methylation, it gives a arecaidine. So where you can see the methylation, the methyl group is added on the para position. Then after the esterification, after the methyl and esterification, we are adding just an ester group here. Then it produces the arecoline. So upon the further reaction, further process, it liberates some other chemical constants. Next to that of, yes, uses of these particular areca nut. We know that it is a parasympathomimetic. What is a parasympathomimetic and what is cholinergic? These cholinergic drugs also known as anti-muscarinic agents. Okay, so where it can, they act on the muscarinic receptor, they act on the cholinergic receptors. So thereby they increase or they stimulate the muscle contraction. Okay, yes. Coming to that, it is also having anti-helminthic property, where it's used as a vermicide and tenifuse in veterinary practices. Yes. This drug is used as an anti-helminthic as well as it is used as a vermicide and also tenifuse in the veterinary practices. Clear? So that's about the areca nut. Coming to that, what is the other names? What are the chemical names of these secondary metabolites which are in the areca nut? So because sometimes they ask based on the chemical name also. Guaifenesin known as tetrahydronicotinic acid. Whereas araquidine is N-methyl derivative. Yes, undoubtedly, because N-methyl, you can see here, N-methyl derivative of the guaifenesin. And whereas undoubtedly the arecoline is a methyl ester of arecoline, because here we performed esterification so that the end product will be the methyl ester of araquidine. Here, yes, we'll quickly revise that. The synonym of this plant is areca betel nut and supari. And whereas the source of this particular biological source is areca nut is Areca catechu, belong to the family Palmae, and is consisting of major chemical constants like guaifenesin and arecaidine and arecoline. So whereas the initial chemical constant is guaifenesin, upon methylation we get the arecaidine, upon esterification we get arecoline. So they have different names chemically. And whereas the uses of this areca nut is parasympathomimetic and also anti-helminthic, vermicidal and tenifuse in the veterinary practices. Not only on the humans, and also it is used for the veterinary practices. Clear? Yes, this is about areca nut. And now moving to that, what was the leaf? Look at here. What was the leaf? So it's a very familiar a nicotine containing plant, that is undoubtedly the tobacco. So we knew that the tobacco powder, the tobacco products are very familiar, not only for their medicinal properties, not only for their medicinal use, but other than the medicinal uses, we are using these tobacco products like cigarettes and other nicotine pumps and other drugs. Okay, but the actual thing is, why these tobacco products are converted, that they are lightening up, why they are they are burning. So we can some are directly chewing these tobacco products, because why the people, the smoker lightening up these cigarette is just because of the property, like this tobacco is a volatile liquid. That's the reason they used to fight that cigarette, so that the volatile liquid can converts and volatiles, and that breeze is inhaled, and that finally acts on the brain. Stimulant effect, that's the reason. Okay, you got it right? Yes, the tobacco is a volatile liquid alkaloid obtained from dry leaves of Nicotiana tobacum, belong to the family Solanaceae. We knew that the major compounds like nicotine, about 0.6 to 9 percentage. 0.6 to 9 percentage can be synthesized from these Nicotiana tobacum. And other than that, anabasine, anatabine are the main chemical constants of this tobacco. Okay, and whereas the uses of this tobacco, so when you look at this uses, the stimulant effect on heart and nervous system, for that reason, the person who smokes a lot, you can see that a physiological changes in their heart and nervous system, because it stimulates the nervous system, stimulates the heart. So whenever any other person, any person who is a smoker, a regular smoker, so whenever he body get addicted, got resistant to this tobacco, whenever he loses control, whenever he never smoked, and immediately shows effects on their heart and nervous system, because it's a volatile liquid which acts on stimulant property on nerves as well as heart. Okay, that's about the medicinal uses. But these, not only the medicinal use, that the physiological action of that is producing on our body, but this nicotine used in the surgeries and some other properties, and also some to stimulate the brain. It is also this tobacco, this nicotine. Okay, now in some other formulation they extract the nicotine, that is 0.6 to 9%. That nicotine is extracted out and then prepared as a medicine to produce some CNS stimulant activities. Clear? Yes, and also apart from that, it produces some insecticidal and fungicidal properties. So for that reason, it is a natural insecticide, natural bio-insecticide, bio-fungicide. Clear? Yes, so these are the major examples of major drugs that we need to discuss with respect to the pyridine and piperidine alkaloids. Then we'll see what are the other alkaloids we need to cover, we need to discuss. Okay, so next in that part we have a tropane alkaloids, which means these alkaloidal drugs containing the tropane nuclease. It consists of tropane nuclease, my dear students. You can see right over here in this tropane nuclease. So what do you mean by tropane? Where the N-methylpyrrolidine and piperidine gets fused to form the tropane nuclease. The tropane alkaloid represents the fusion of pyrrolidine, this is the N-methylpyrrolidine, and piperidine. So this is a bicyclic structure with methylated nitrogen. With is a methylated nitrogen here. Okay, so N-methyl group is there. Okay, and coming to that, the alkaloid containing methylated tropane nucleus are chemotaxonomic characteristics of family of Solanaceae. That's what we discussed. In the chemotaxonomic classification, we said that specific group of family are containing, are they synthesizing a specific secondary metabolites or specific chemical quantities. Like how the Solanaceae family are undoubtedly, they are having 80% of tropane alkaloids, tropane nuclei containing compounds. The Umbelliferae family consisting alkaloids, like how the alkaloid containing methylated nucleus, tropane nucleus, are chemotaxonomic characteristic of Solanaceae. So where we can see all the Solanaceae family are having this tropane nucleus. When you synthesize or when you get those tropane alkaloids, especially the Solanaceae family containing plants, so they're having this tropane nucleus in their structure, in their chemical constant. Okay, and now the therapeutic value is present only in hyoscine, hyoscine, and racemic form of hyoscine, that is atropine, which is optically inactive. Okay, and hyoscine, that is atropine. Okay, yes, coming to that, so you should remember that. So what are the things which is one optically active, which is optically inactive? That's the reason we have included here. Okay, so in the previous alkaloid introduction, I made a slide, I made a table form where I have given explanations with some of the exceptions for the alkaloids, color exception, property like physical property, whether it's liquid or solid, and solubility, and their stereoisomers also. So please look at that particular slide, and so that you can remember that. So then it is very helpful for you to differentiate their special features. Okay, yeah. So we are having so many tropane alkaloids, but apart from that, we are, especially the hyoscine and hyoscine containing alkaloids are possessing the therapeutic value. Okay, so but coming to the examples, what are the plants we need to discuss in the tropane alkaloids? Well, that's one is, we know that belladonna, datura, hyoscyamus, stramonium, 𝙂𝙎𝙎𝙬, and coca. So these are the very important tropane alkaloidal plants that we need to discuss in this session. Because in the previous examinations, like in the especially for GPAD and other examinations, they only focus on these special plants because they have a wide range of wide applications. Okay, yes. The specific, yes, coming to that, with respect to that of the tropane alkaloids, we need to know about is there any special test? Tropane alkaloids. There is a special test, my dear student. You should never forget that test. That is 𝘂𝙀𝙎𝙬𝙀 test. Tropane, 𝘂𝙀𝙎𝙬, tropane, 𝘂𝙀𝙎𝙬. You should remember that. Okay. So like how any tropane nucleus containing drug, any tropane nucleus containing alkaloid, that should be tested under the 𝘂𝙀𝙎𝙬𝙀 test. That's a basic primary chemical test, basic confirmation test for the tropane alkaloids. That is, tropane alkaloids, one is treated with fuming nitric acid, and then it's evaporated to dryness at 100 degrees centigrade. Then finally, if you add 3% of KOH solution, gives a violet color. Whereas V refers to 𝘂𝙀𝙎𝙬𝙀. The finally the color is also V, violet color. Okay, so but it's used for the testing of tropane alkaloids. And apart from that, through 𝘂𝙀𝙎𝙬𝙀 test, we are having another test called 𝘎𝑟AD test. The 𝘎𝑟AD test is nothing but the tropane alkaloids, and is treated with 2% solution of mercury chloride in 50% of alcohol. It produces a white precipitate. If it produces a white precipitate, that is hyoscine. If it is produce a red color upon heating, that is hyoscine. If it is produced, it liberates a red color without any heat, that is atropine. So these are the preliminary phytochemical confirmation test for the tropane alkaloids. Clear? Yes, you should definitely remember this type of test, because they'll ask which 𝘂𝙀𝙎𝙬𝙀 test is for tropane alkaloids, pyridine alkaloids, indole alkaloids, and quinone alkaloids. Like how they used to ask. So that if any specific preliminary identification test for a specific group of alkaloids, you should definitely remember, my dear student. Yes, first and foremostly in this drug is belladonna. We knew that the belladonna, this is a belladonna. So can anybody, I think if you came across the 6th semester, the 4th semester and the 5th semester of your B Pharm, you should know that when you've gone through with the Pharmacognosy 1 and 2, immediately when I say the belladonna, you should definitely remember, you should definitely strike about their synonym. That is, what is the synonym of this particular belladonna? Yes, just simply do remember this image. Okay, so if you have this image in your brain, then you can able to answer the synonym. What is the color of this fruit? Black color. Okay, black. So the night will be the black in color, the day will be in light color, the night color, the night time. Okay, so because it is a deadly nightshade leaf, the synonym of this plant is deadly nightshade leaf. Why? Because so there is a fact about, or there is some of the interesting facts about the belladonna. If you ask me like this, so why the deadly nightshade leaf comes, the name is assigned to that particular belladonna? Because these fruits are very toxic, because there are 2 to 3 fruits are enough to kill an infant. Whereas at 10 to 50 fruits of these belladonna are enough to kill a adult. So for that reason, it is a deadly nightshade leaf. It can kill an adult infant and an adult with a specific amounts of the fruits. Okay, so even though they are toxic, in the alkaloid, the name itself is a toxic, but in the minute concentration they produce a pharmacological action. So for that reason, the minute concentration only taken to produce a medicine. Okay, coming to the biological source. The belladonna is obtained from dried leaves of Atropa acuminata, Atropa belladonna. Whereas this Atropa acuminata is an Indian belladonna, Atropa acuminata is Indian belladonna, Atropa acuminata is Indian belladonna, Atropa belladonna is European belladonna. So these are the sources that we can get this belladonna. Okay, yes, coming to that, whenever any two of the sources will be given, you should definitely remember which is accountable for the major chemical constants. Because some other species like cinchona, it is having four sources: Calisaya, Saxirubra, Legeriana, and Officinalis. So, but which one is counting major accountability? Legeriana. Like how whenever any of the two other than one source is there, should definitely remember that which one is accountable for the higher amounts of the chemical constants. Okay, and which one is having a different name. Okay, so which one is Indian belladonna, which one is European belladonna. So like how you need to remember, we'll discuss about other things. The family is belong to the family Solanaceae. The Solanaceae, whenever you heard the term called Solanaceae, immediately your mind should strike off, it is a tropane nucleus containing alkaloid. Next, coming to that, in this particular belladonna, I have included the microscopy because in some of the cases, for this datura and some other plants like digitalis, some plants they are asking about the microscopy. Coming to that, epidermis, it is consisting of epidermis cells with slightly sinuous anticlinal and wavy wall and striated cuticle with anastocytic stomata. Anisocytic stomata. So that's the reason in the GATE examination, previous is known as GATE. Okay, so later on the 2010 afterwards it converts and it is known as GPAT. Okay, so GATE, in the GATE 1999. So the question is given like which of the stomata is consisting in the belladonna. It is consisting of anisocytic stomata. It is consisting of anisocytic stomata. And also it's having what are the trichomes nature. It is having less non-glandular and more glandular trichomes. It is having more glandular trichomes. More glandular, less non-glandular. It is consisting of both glandular, non-glandular, covering and non-covering. So, and whereas these trichomes are uniseriate with unicellular head. Uniseriate and unicellular heads are there. Single is striated. Simply, Elra, like how a uniseriate and unicellular head. So like how the trichomes are there present in the belladonna. And occasionally covering trichomes, like what are the other things? Occasionally covering trichomes are maybe uniseriate and multiseriate heads. Okay, and these cells are spongy mesophyll filled with microspinoidal crystals of oxalate. Yes, you should definitely remember this word. Mark this word, microspinoidal crystals, because the coming to the characteristic features of the microscopical factors of plant, especially the quantitative features. The calcium oxalate crystals will be exhibited in different forms like rosette form, spinoidal form, microspinoidal form, cubical form, rosette. Like how, what is the special feature here? The calcium oxalate crystals will be in a microspinoidal structures, crystals, and the palsy ratio is about 5 to 7%. 5 to 7%. You should definitely remember these things. Okay. Coming to the chemical constants of these particular belladonna, it is consisting of mostly 0.3 to 1% of alkaloids is consist, and whereas the main alkaloids like 𝘿𝙄𝙎𝘾 and the racemic form, that is atropine. So after the racemization only, this 𝙄𝙎𝘾 converts into the atropine. So sometimes they ask like, what is the racemic form of 𝙄𝙎𝘾? What is the racemic form of 𝙄𝙎𝘾? Which one is the most active form of 𝙄𝙎𝘾? Like how they used to ask, you should definitely remember that the atropine not directly available in the plants, but it can be synthesized It can be produced by the racemization of 𝙂𝙎𝙎𝙎𝙬 to the atropine. Yes, and coming to that, it contains also other constants like fluorescent substance called scopolamine. Scopolamine, that is a N-methyl acetylene. So that's a fluorescent substance. So where it can react in the fluorescent substance. So that's about the scopolamine. Whereas coming to the uses of these belladonna, we know that the belladonna is an anti-muscarinic, anticholinergic agent which acts on a parasympathomimic drug with anticholinergic property. Involuntary muscle contractions because of the cholinergic transfers, because of the cholinergic receptors, muscarinic receptors. So these are responsible for the muscle contractions or nerve impulsions. Whenever these uncontrolledly the muscle get contracted, in such cases this drug act as anticholinergic and it prevents the muscle contraction, seizures, and all these things. And it can be used in the surgeries also because it's an anticholinergic. It reduces the muscle contraction, nerve impulses, like how it acts. And also the major thing is antidote for opium and chloral hydrate. Yes, you should definitely remember this. They'll ask which one is the atropine is antidote for. They'll give you options: opium and chloral hydrate, and some other drugs they'll give you, but you should remember that opium and chloral hydrate as the examples. Okay, these are the major drugs that we can cure with. These are the drugs where the atropine acts as antidote. That's about the atropine. And next we are going to see the next drug, that is datura. So we all know that these are all comes under the Solanaceae family. So we are well known with this plant because we can regularly and we can see this plant. Okay. Yes. The synonym of this datura is known as moonflowers because we can see the datura in our +2 standard. We have performed these datura flower dissection and their inflorescence, and to check the floral formula and to check what are the other aerial parts they have performed. We are well known with this datura plant. Okay, and that's nothing but moonflowers because they are white in color and known as angel trumpet and Jimson weed. You should definitely remember that synonym of this plant: angel trumpet and Jimson weed. Especially these type of special names are assigned to that of the particular specific drug. Definitely you should remember angel's trumpet, Jimson weed. Okay, so these all are assigned to the datura. And whereas the source of this datura is consisting of dry leaves and flowering of datura metal. This is a datura metal plant. Okay, belong to the family Solanaceae. Whereas when we see about this microscopy of the datura, it is a very important feature we need to remember with respect to datura, because so many questions they are asked about the datura microscopy in the previous GPAT examinations. So coming to that, it is also consisting of anisocytic stomata as like the previous one. Okay, and the trichomes are also here. Also we can see the glandular and non-glandular trichomes, and sponge parenchyma contains the calcium alkaline crystals. So these are all the covering trichomes, that is unicellular and multicellular, uniceriate and multicellular. And so these are the other type of alkaloids, that is the lamina part, which is here up to the lamina part. And we can see the xylem here, lignified xylem, non-lignified phloem is there. This is a non-lignified phloem. Okay. Yes, but what is the xylem meant for transport? What are the phloem meant for the transport of all the food ingredients and other nutrients? And this stomata is nothing but anisocytic stomata, where we can see right over here. Okay. So, and it is consisting of sponge parenchyma here itself. The sponge parenchyma. These all are sponge parenchyma and the calcium oxide crystals right over here. It is a calcium oxide crystal. Okay. So in the sponge parenchyma, it consists of the calcium oxide crystal. So this is about the microscopy. Please have a look on that. Coming to that, what are the chemical constants of the datura? If you ask me, what are the chemical constants? So contains of 0.5% of total alkaloids, and also consists of hyoscine, that is known as scopolamine, the main alkaloid, and 𝙂𝙎𝙎𝙎𝙬 and scopolamine. And whereas the scopolamine is a fluorescent substance. Okay, and 𝙂𝙎𝙎𝙎𝙬 and atropine in very less amounts are there. Okay, So that's about the chemical constants. And coming to the uses, these uses are especially parasympathetic. So this also possessing the same property as like the belladonna, anticholinergic property, parasympathetic lytic property, and which acts as CNS depressant effect. They produce on CNS depressant effect. How they act as by anticholinergic drug. They reduce the nerve impulse, they reduce the transmission, neurotransmission. Thereby they reduce the function of brain. Then it leads to the CNS depressant property. And also it used in the asthma and cough. They asked in the asthma and cough also they used in the treatment of asthma and cough. And hyoscyamin hydrochloride used in the motion sickness and gastric and duodenal ulcers. So these are to be noted. These things to be noted. And what are the adulterants? Because whatever we present here are nothing but we have prepared the things, we have included the things just because we observed the previous papers, which means in the previous papers, especially from Datura, they asked about the what are the adulterants and substances also. You should definitely remember that. In generally, they used to they used to substitute with some other leaves like Solanum nigrum and Ailanthus glandulosa, and Phytolacca americana. So these are the substances and other adulterants. But how can we distinguish? How can we identify the datura from these species? Because the Phytolacca americana is distinguished by the anamocytic stomata, but where the datura consisting of anastocytic stomata. Okay, and where the Solanum nigrum will differentiate from these datura, it is because of the palisade ratio, and Ailanthus glandulosa is differ from the lignified trichomes. Okay, so these are the different adulterants and substances. And what are the other uses? Yes, and anticholinergic effect. Sorry, for the next drug, that is stramonium. So that's about the datura. And next is stramonium. So this is a other plant in the tropane alkaloids. Okay, yes, stramonium, where you can see the leaf, maybe it looks like a star. Stramonium. Okay, that's known as thorn apple leaf or stramonium leaf. Thorn apple leaf and stramonium leaf. This stramonium consists of dry leaves and flowering tops of stramonium, belong to the family Solanaceae. And whereas the chemical constants, you should definitely differentiate the synonyms of the tropane alkaloid, even though up to now we have covered the 3 to 4 drugs. Okay, but you should definitely remember which synonym meant for each. Deadly nightshade leaf, thorn apple leaf. Okay, so like how. So coming to this, also belong to the family Solanaceae because it's a tropane alkaloid. And chemical constants are found in between 0.2 to 0.5 percentage. And the hyoscyamin and hyoscine are the main alkaloids along with small amount of atropine. Yes, I said that there is only presence of hyoscyamin and hyoscine but not a crude atropine will be available. But after the racemization only we can get the atropine. Okay, and it has same as like the previous. All the tropane alkaloids are possessing same property, that is anticholinergic property. Apart from that, they are having other properties. Okay, anticholinergic property and also used in treatment of asthma. And it has a anti-𝘂𝙎𝙎 property. Anti-𝘂𝙎𝙎, which means it controls the salivation. In the some of the people which are suffering with seizures, fits, and some of the conditions like in the surgeries, when a person loss of the control, he uncontrolledly, without any his control, the saliva gets secreted from the mouth of the colon. So in such cases, we used to administer this drug called stramonium, where it acts as anti-𝘂𝙎𝙎 and control the salivation and muscular rigidity and tremors in the Parkinson's disease. Tremors, because it is an anticholinergic drug. It can act on all the nerve impulse and neurotransmission, so that it can act as a anti-Parkinsonism drug. So this is about stramonium. And next one is hyoscyamus. So these are all the same family Solanaceae but different species which are having a tropane nucleus. Okay. Yes, this hyoscyamin, the very important, the synonyms henbane, deadly nightshade leaf. Okay. Jimson weed, thorn apple, devil's trumpet. Sorry, angel's trumpet, not a devil's trumpet. Okay, like now the coming to 𝙂𝙬𝙎𝘾, the synonym of this plant is henbane. But where has it obtained from this henbane plant or 𝙂𝙬𝙎𝘾 niger? 𝙂𝙬𝙎 niger. It obtained from the dried leaves and flowering tops. Dried leaves and flowering tops of 𝙂𝙬𝙎 niger belonging to the family Solanaceae. We know that. The name itself 𝙂𝙬𝙎, it's saying that 𝙂𝙬𝙎, 𝘿𝙂𝙎𝙾. 𝙂𝙂𝙎𝙾 is there, but after the if you need to get the atropine, we need to convert or we need to perform the subject into the atropine, sorry, racemization, so that we can get the 0.6 to 9% of the other alkaloids. Like here itself, it should contain not less than 0.5, 0.05 to 0.15 of the 𝘿𝙂𝙎𝙾. So it contains very less amounts of 𝙂𝙬𝙾 or less amounts of tropane alkaloids. But what is a major distinction or use of this particular 𝙂𝙬𝙾 is it is relieves the spasm of urinary tract. All the tropane, do remember that, my dear students, all the tropane alkaloids are having anticholinergic properties. There it can release the muscle spasms or seizures or Parkinson's disease or muscle contraction. They reduce the muscle contraction. They act as CNS. Like how? You need to remember that. So here it releases spasm of urinary tract because in anticholinergic property, na? And it is used to contract gripping due to 𝘾𝙀𝙉𝙁. So that's about the 𝙂𝙬𝙎𝑃. And the last one in this is 𝘂𝙄𝙎𝙎. 𝘂𝙂𝙎𝙎 is also a plant which comes from the Solanaceae family, but it is also containing a tropane nucleate. This is a plant called 𝘂𝙂𝙎𝙎. Okay, so it is known as corkwood. Synonym of this plant is corkwood, obtained from 𝘂𝙂𝙎𝑠 myoporates. 𝘂𝙂𝙎𝑠 myoporates, the biological source, and family Solanaceae. The chemical constants are scopolamine, atropine, but where the hyoscine is commercially obtained from the 𝘂𝙂𝙎𝙎. We can only contain this. We are getting the hyoscine for the commercial purposes 𝘂𝙂𝙎𝙎, and also contains 𝘿𝙂𝙎𝙎𝙾. It contains hyoscine commercially. Okay, that is known as scopolamine, and it contains 𝘿𝙂𝙎𝙾, which is converted into atropine during extraction process. So that we already know. Coming to the uses, as I said, that all the tropane alkaloids having anticholinergic property, but it acts as a antidote for pilocarpine poisoning, phytostigmine poisoning, and other choline esters Okay, because if these choline esters are increased in our body, that pilocarpine and phytostigmine leads to, these are cholinergic drugs, which can increase the muscle contraction, thereby leads to seizures, spasms, and tremors in such a way in order to reduce this effect. Okay, so we use this drug as an anticholinergic drug, okay, antidote for all this time, and it relieves the bronchial spasm in asthma, and it is used to reduce the tremor and rigidity in Parkinson's disease. That's we need to. Okay, 𝘂𝙂𝙎 is the other chemical constants consisting of 𝘂𝙂𝙎, 𝘿𝙂𝙎𝙾, and all these things. My dear students, do remember that. Okay, and then last in this tropane alkaloids, that is coca leaves. We knew that coca, it is very familiar for all of us because we used to eat all the chocolates, cocaine containing chocolates, coca containing fruits. Okay, so this coca is nothing but also known as the synonym of this coca leaves are coca. So where you can see this coca leaves or fruit here. The coca is obtained from the dried leaves of erythroxylin coca or Bolivian coca, and whereas erythroxylin truxylinase, that is Peruvian coca. So from these two sources we can get the coca. Family Erythroxylaceae. Chemical constants are cocaine, cinnamoyl cocaine, alpha truxylin, there is a tropocaine, benzyl tropane. These are all the chemical constants, main chemical constants. Yes, in the quick revision session, if you attended or not, my dear aspirants, we have discussed that in the quick revision. We have gave you that chemical constants. Okay, cocaine, coca, it's obtained from coca. Cinnamoyl cocaine, obviously obtaining from coca. Alpha truxylin, because it is obtained from the erythroxylin truxylins. So alpha truxylins, tropocarpine and benzyl tropane. But this thing should be important. So what are the other end products, and what upon subjecting to them, upon subjecting each secondary each chemical constant, what will be the liberated products. Okay, upon the cocaine, when we are subjecting them into other reactions, it liberates 𝘂𝙄𝙎𝙎, methyl alcohol and benzoic acid. But whereas the cinnamyl cocaine will liberate 𝘂𝙄𝙎𝙎, methyl alcohol and cinnamic acid. But whereas alpha troxyline will liberate the two are common and alpha troxyline. If you observe or not, the first two things, that is 𝘂𝙄𝙎𝙎 and methyl alcohol, is common for all of the thing, but depends upon the prefix. Remember, cinnamyl, cinnamic acid, troxyline, troxylic acid. So that will they are liberating. Okay. Yes, like how we need to remember what are the uses of this coca. The coca is an local anesthetic. It is an local anesthetic, my dear student. So this one is about for today's session. Okay, so we have seen the coca and we have seen about other duboisia, datura, atropa, stramonium, hyoscyamus. Okay, so belladonna. Okay, and also we have seen other pyridine pyridine alkaloids. So this is about for today's session. We'll see in the next upcoming classes for more such content. Okay, do follow and do get enrolled in other courses. Okay, so in some other new courses that we have launched in our GDC platform, do register and do get enrolled and have a knowledge and happy learning. Thank you.